Well, hello everybody. We're going to start right in with this warm up. I'm just going to start doing this with you, so if you could get settled down here and we will start this together. We have a situation where somebody is paying into a savings account and they are depositing every month, same amount, $250. So in this case, they're getting an interest payment, 3.6% interest. That's per year. So if I'm paying per year 3.6%, then my R value is 0.036, but I'm getting interest compounded monthly. So my monthly interest amount is going to be what I'm using for I here. This is my monthly interest amount, 0.036, sorry about that, 0.036 divided by 12. If I divide that out, it's going to give me 0.003. That's my monthly interest rate I. In this case, we are going to put money into account every month for 5 years. 5 years, every month I'm getting interest, so the number of times that I'm getting interest, which is N, is going to be 5 years times 12 months every year for a total of 60 periods. So here's the formula that we have to figure out how much our money is going to be worth in the future. So this A of F, that is our future amount. And you're going to want to keep this formula handy because we're going to be using it throughout this lesson. Future amount is going to be equal to whatever our regular payment is, that's R, so that's our regular payment. In this case, that's equal to $250 per month. We're going to put all of this into our formula to find how much is in this account after 5 years. So calculating that A of F amount, we are going to put in 250. Multiply that by 1 plus I, or 1 plus 0.003, for a total of 1.003, all raised to the n power. That's 60 payments. We're going to subtract 1 from that and divide that by that interest rate that we get each month. Complicated formula, I know. If you put all of this in your calculator, what you want to do is treat this so that your R values be multiplied by that entire fraction there, and you should end up getting $16,407.90. Take a few minutes here and make sure that you can get that amount. You can enter that in your calculators properly. I'll give you a few seconds on that. Okay, what I need you guys to do is have that formula ready for you, and also another formula I'm going to give you. I'm not going to derive these for you until I'm back with you. But there's another formula that gives you an amount which is called a present value instead of future value. So this AP here, let me get a pen now. AP is a present value. So the now value, if you want. And R in this formula is just like it was before, whatever that regular payment is. I is the interest rate that you get each period. So I typically equals your APR value, or what we've been using for our annual interest rate, divided by number of periods that we are getting interest, which is N. And let's see, N here is number of periods. Same as we calculated in the warm-up. So that's one formula, a new formula that we'll be using also today. If you see a word problem that talks about present value, you want to use this formula. One formula also I want to bring back to your attention, one that we've used in the past. It's the amount that you would have in a savings account if you put money in at the beginning, just one amount, your principal, starting amount, did not add to it every month or periodically, and left it in the bank. And this formula you should have seen before. This R over N here, same thing as the I that we're using in the formulas above. NT is the number of total periods that you're getting compounded interest. So this thing, R over N, also equals I that we're using above. Okay? Alright, so what we're going to do then, go to your next page, and we're going to just start in with some examples, because these formulas are all about figuring out things from an example. Here we've got Jack wanting to buy a car. $9,000 cost of the car, and he's going to need to take out a loan. Annual interest rate R, 3.6%, so I'm going to change that right now to a decimal, 0.036. Then he's going to pay for 5 years, pay monthly. So his total number of payments is going to be 60 here. He's going to this car dealer and he's asking for a loan for this car. So here's what the dealer's thinking. First thing is, okay, I really want to get $9,000 paid up front, but this guy needs a loan. So supposing I put my $9,000, me being the dealer, supposing I put $9,000 that I had right now for this car, and I put it in the bank. And I put it in the bank and got 3.6% interest, and I left it in there for 5 years. If I did that, the amount of money that I would have in my bank would be the amount of money that I get when I use this A equals P times 1 plus R over N, all to the NT power, because I'm not adding money every month, I'm just putting the 9,000 in. So that means that I would have 9,000 times 1 plus 0.036 over 12, all to the 60th power, which is my 5 years times 12 months. If I do that, figure all that out, that money in the bank in 5 years would be worth $10,772.05. So when Jack comes to me and says he wants to borrow money, I think, if I had that money now and put it in the bank, 5 years I'd have $10,772. So the next thing we want to do then, if I'm the dealer and I'm willing to make this loan, I want to figure out how much would be in an account after 5 years if I let Jack make payments, and each time he made a payment, I put that money into the bank, and I would put it in at that same 3.6% interest and get interest every month. I want to figure out how much money would I have after that 5 years. And I'm just going to use the formula for future value when I'm making a payment regularly. So that's this formula, that AF, future value, when I'm, in this case, getting a payment, so that payment was R, and I'm multiplying that using the formula 1 plus what my I was to the n power minus 1 all over I. So same formula we used in the warm-up, same scenario. Okay? If I do that, I'm going to write an expression. I don't know what Jack's payments are yet, so I don't know R. I'm going to write that as an expression in terms of R. So this would be equal to R times 1 plus I. Now don't forget my I is equal to 0.036 over 12, or 0.003. My N is equal to 5 years times 12 months each year, or 60. Whoops. See if I can get my pen back here. This is equal to 60. Alright, so I'm substituting these numbers in and leaving r, so I have my answer in terms of r. This is going to be r times 1 plus I would be 1.003, all to the n power, which is 60, minus 1 over 0.003. So if I take all that and multiply it by r, that should equal how much I want to have in the bank. Okay, so I'm going to use this to figure out how much Jack should be paying per month. And I want to be fair to Jack. And in order to do that, I'm going to say, okay, well, if I let Jack take out this loan, I want to have payments coming in that I can put in the bank regularly and get interest on. But I want to make it equal exactly what it would have equaled if he paid me $9,000 up front and I put that in the bank for 5 years. And that's the part we figured out in part A above. So what I want to do is let this amount here equal that $10,772.05 and then figure out what the payment should be in order to get that. So I'm going to write down 10,000. Let's move this up here, make sure I got a pen. $10,772 is what I want to have this equal. If Jack's making me payments, which would be R times, and this is the part from B up above, 1.003 to the 60th power minus 1 all over 0.003. Okay, I need to solve for R. So what I would do in my calculator is take my 0.003, maybe multiply both sides of my equation by that, and then figure out what 1.003 to the 60th minus 1 is. That's my coefficient of R. Divide both sides by that number, and I'll get my R value. I'm going to let you guys work those in your calculators, what you should end up getting for R, or the monthly payment. I'm going to make this about equal to, because I'm doing some rounding here, $164.13. So what that says is, if Jack can pay for 5 years every month $164.13, I will have in my bank account the same amount of money as if I took $9,000 at the beginning of 5 years and put that in the bank. Alright, so this kind of example talks then about how we figure out monthly payments and how we look at finding future values. This part D in your notes here, find out how much Jack needed to pay each month. We kind of did that up in part C above. But what we wanted to make sure, and I'll write this down for you, in order to be fair, the total money in part B should equal total in part A. Okay. Now we're going to step ahead, look at another example. This time we got a college student who is buying a car. We know the monthly payment, we know the interest rate, and we want to figure out how much can this student afford in a car. So here's what we've got. If I read this information, this student's going to pay $200 a month. That's my regular payment, so R equals 200. And we're going to take out a loan. The interest rate per year is 6%. So R is, if I put this in as a decimal, 0.06. But we're going to make monthly payments. So I need to figure out what's the interest rate per month. That would be my I value. And I'm going to take that annual interest rate divided by 12 months in the year. and that gives me 0.005 for my interest rate per month. And we're going to do this, this says for 4 years, and we're paying monthly. So for 4 years, paying every month, my number of payments, N, is going to be 4 years times 12 months, 48 payments altogether. Now, I need to figure out, in this case, how much can I afford right now? Not how much is this going to be in the future, but how much is this worth right now in the present. So I've got another formula on the front sheet of your notes, but it's this AP, or present value. Okay, and if you're not sure which one you're using, read through the example and try and figure out if your words are telling you something about value in the future or value right now. In this case, the last question is, what price can we pay for this car? And it's not written there, but basically we're buying this car now, so that means present. So we're going to use this formula A present, and that is equal to, if you look back at the front of your notes, R again times, now this part's a little bit different, we're going to get some negative exponents, 1 minus, in parentheses, 1 plus I to the negative n power over I. A little bit different. Again, I'm not going to go through and derive these for you. I will give these formulas to you on a test. You just need to figure out which formula would be the best one to use. So now I'm going to go ahead and figure out what the present value of this car is. If we're paying $200 a month, that's our regular payment, $200. And I'm going to multiply that by 1 minus. Now, I find it's easier if I take my 1 and add that I right off the bat and make it one number. So I'm going to add 1 to 0.005 and make that 1.005, and that gets raised to the negative 48th power. And I'm going to divide all of that by 0.005. If you put all of that in your calculators, you should get an amount of $8,516.06. And this is how much this student can afford in a car right now. So this is amount student can spend on a car now. Okay. All right. Now we're going to take a look at another example. This time, set this up so that you could choose what kind of car you would like to take out a loan for, and work the numbers with several types of loans. Since we're going to be doing this together, not individually, I'm going to look through this list of cars, pick out, let's see, selling prices, $9,750. Assuming I win the Powerball and money is no object, 10,000 is a nice number to work with. I'm going to pick this car. That's the one I'm going to choose to use in this example. Going to try buying this $10,000 car, but we've got some expenses on top of that $10,000, and this is typical. We got sales tax. Monroe County, we're paying 8% sales tax. And then we also get to pay the state for a license, title, all kinds of other fees. We're going to estimate that to be 3% of the selling price. And we need to figure out here how much we're going to borrow for this car. And I do, in this example, I do have $1,000 to put down. So here's what's happening. I've got the price of the car is $10,000. And then I have sales tax on top of that, 8% of total. So my sales tax is going to be 0.08 times my $10,000 car. Sales tax alone is going to be another $800. And then I have all that license nonsense, well, not nonsense, but license taxes and fees, 0.03 or 3% of my 10,000, which is another $300. So the total amount for my car, I'm going to write this over here, total cost, we've got 10,000 for the car, 800 for the taxes, 300 license fees, gives me a total of 11,100 total cost. But I am going to put $1,000 down, so the amount I need to borrow is going to be my total minus my down payment. So amount to borrow, 11,100 minus my $1,000 down payment. That's up here. So that gives me total borrowed $10,100. Alright, so now I've got some loan options here that I need to figure out so that I know how much I'm going to be paying in interest and how much per month, all that nice stuff. Okay, I need to calculate monthly payment for these different types of loans. And if you notice, and this is typical, the longer your loan, the higher the interest rate. If you can afford to pay any kind of loan off in a shorter time, you usually end up paying less interest. However, your monthly payments are not always going to be the same. So here's what I'm going to figure out. I'm going to be paying monthly. Okay, so I'm figuring out monthly payment. And I have different options here. I'm going to figure out what that I value is for each of these. If I have R equaling 2%, then the interest rate I that I pay per month is going to be 0.02 divided by 12. That's for that first scenario. And the number of payments on the 36-month loan, 36. For loan number 2, 0.03 over 12 is my I value, and is 48. And third loan, 0.05 over 12 is my I value, and is 60. So I'm going to go ahead and figure out, if I'm borrowing $10,100, how much each of these loans is going to cost me. So let's go with starting loan number 1. I have $10,100 that I'm borrowing. I'm going to need to use that present value formula because $10,100 is my present value. So really, AP, present value, $10,100. So I'm going to use that formula that uses AP and set 10,100 equal to my regular payment, whatever that is, multiplied by 1 minus, and I need to put 1 plus my I value in here. I'm thinking I got a repeating decimal, so I'm going to put this in as a fraction and put the whole thing in. 1 plus I, 0.02 over 12. That gets raised to the negative 36 power. And divided by I, which is 0.02 over 12. All of that gets multiplied by R. Lots of steps going on here. I would recommend that you first put in your calculators in parentheses 1 plus parentheses 0.02 divided by 12. Close your 2 parentheses and then raise that to the negative 36 power. Then take 1 and subtract that answer, and then take that answer and divide by, in parentheses, 0.02 divided by 12. That becomes your coefficient of R. You can take your 10,100 divided by that answer, and that gives you R. In this case, I got a monthly payment, or an R value, of $289.29. So that's for loan number one. Now I'm going to look at loan number two. Loan number two, still borrowing the same amount, but different interest rates and different number of payments. So I'm putting in a few different numbers here. This will be 1 minus 1 plus, this case, 0.03 over 12. That one you might want to figure out as a decimal and add it to 1, and then just take that to the minus 48 power. Okay, so if you put that in your calculators, loan number two, I got a monthly payment of $223.56. So in this case, I'm paying less per month than with loan number one. I am paying a higher interest rate, but I'm paying less per month, and I'm paying it longer. I'm paying it for 4 years now instead of 3 years. Well, let's go through and figure out now option number three, or loan number three. And I'm just changing my interest rate and my number of payments. Loan number three, 5-year loan, 5% interest. The monthly payment went down to $190.60. So, there's going to be some questions that are asking you things like which one is the better loan. It really all depends. If you were to calculate how much you paid in total for each of these, in other words, for loan number three, if I took $190.60 and multiplied it by 60 payments, I'm going to get total amount of money paid. If I do that the same for my other two loans, you're going to find that the first loan actually has you paying the least amount of money of all three. But the nice thing about that last loan here is that it puts the monthly payments lower. So if somebody can't afford the higher payments that you get with loan number one, they might need to extend their loan out longer with a higher interest rate just to bring the payments down and make it affordable. Okay, last question on this one. Which one would keep your payment under $199? That was loan number one, or excuse me, loan number three. That was the only one under $199 a month. You might want to go with one with fewer months though, because total cost over what they call the life of the loan is lower for loan one and loan two. All right, that wraps it up for us today. I'm hoping that you will be able to use the formulas on the front of the page, and this one here, which we got today, to do the homework problems. So take the rest of the time, please, to work on the homework or catch up on any past homeworks, and I will see all of you tomorrow. Have a great day, guys.